Hi guys, today we would like to show you another sharing knowledge video, or we can call it even educational video, in relation to the Directive 2009-125 EC, which is the EcoDesign requirements for air heating and cooling products, so we can call it EcoDesign requirements for heat pumps. Damven did his own homework, and we would like to share with you today this information table that is a mandatory for each heat pump, either a classic heat pump or a hybrid, like in our case. So today we would like to share with you how to use this sheet and what are the most important parameters into it and how they are calculated. So let's start with the beginning. It is a very good, if it's possible for you to take and have this directive and to get through it. So we will start with the information to identify the model. Here is our model, Maxi 306. Outdoor side heat exchanger, it's air-based. Indoor side heat exchanger, also it's air. This one, indication if the heater is equipped with supplementary heater, is very important for every manufacturer. So here it's, let's say, the cornerstone of whether your heat pump can work with or without an additional heater. So in our case, as you already know very well, we do not use a supplementary heater, so we say no. Then we go to the parameters inside this table, and the first one is, of course, the rated heating capacity. And be careful, the whole information table number 14 is only for the heat pump part, for the refrigerant circuit. It is not about the heat recovery in this table. So we are talking about pure refrigerant circuit reversible heat pump in heating mode. So the rated heating capacity, in our case, it's at plus 7 degrees ambient temperature. We provide the capacity. This one, the seasonal space heating energy efficiency, for us is the most important parameter in the whole table, but we will get back to it at the end, because over there we need to spend some more time. Then we go below, and you will see that we need to provide the declared heating capacity for part load at indoor temperature 20 degrees Celsius and different outdoor temperatures. In the original table, the outdoor temperature starts from -7 and goes up to +12. But in our case, because of the fact that our heat pump works very stable under temperatures of -15 degrees, we decided to include additional 2 rows at -12, but also -15. So these are additional for this table. To achieve correct values inside this table, we decided to, at each of our calculations, to be based on supply temperatures of 22 degrees. So basically, for each of the ambient temperatures and fixed indoor temperature of 20 degrees and fixed supply temperature of 22, we have calculated different heating capacities. So here you see interesting temperature called bivalent temperature, and we would like to give you the definition from the standard itself. What is a bivalent temperature? So bivalent temperature means the outdoor temperature declared by the manufacturer at which the declared heating capacity equals the part load for heating, and below which the declared heating capacity has to be supplemented with electric backup heater capacity in order to meet the part load for heating expressed in degrees Celsius. So for us, this temperature is minus 15 degrees. Be careful, because for other manufacturers this temperature will be higher, probably minus 5 or minus 7 or minus 10. But for us at minus 15 we are still able to work stable and still able to provide heating capacity. And then the operation limit temperature is another interesting one, which means the outdoor temperature declared by the manufacturer for heating, below which the heat pump will not be able to deliver any heating capacity, and the declared heating capacity is equal to 0. So for us, this operational limit is minus 20 degrees Celsius, and respectively the capacity is 0 kilowatts. So on the right side we have the COPs at the different ambient temperatures respectively to the heating capacities. So you're able to see the COPs at different ambient temperatures and fixed indoor and supply. So here are the real values. We go below, and another important and interesting parameter, or maybe description to talk about, is the capacity control. What is written about capacity control for the heat pump? The capacity control could be three types. First one is fixed if the volumetric flow rate cannot be changed, which means that probably this unit has only one on-off compressor. Then second one is called staged, if the volumetric flow rate is changed or varied in series of not more than 2 steps, which means that probably we have a heat pump with 2 compressors on-off. Or variable, if the volumetric flow rate is changed or varied in series of 3 or more steps. And in our case it's variable because we use frequency controlled or inverter compressor. So be careful for this one, capacity control. Of course, here on the right side for air-to-air heat pumps, the airflow rate outdoor measured in our case is 6,000 cubic meters per hour. Of course, every heat pump should provide the sound power level indoor outdoor measured. We believe that this value indoor outdoor measured is probably given for classic air-cooled heat pumps, but in our case, in the notes below, you will see that our value is measured at 1 meter from the unit without ducts at maximum airflow at 7,000 cubic meters per hour. So as promised, we go back in the beginning to give you a little bit more information of the seasonal space heating energy efficiency. The definition of that is the ratio between the reference annual heating demand pertaining to the heating season covered by an air heating product and the annual energy consumption for heating. So basically this is something like the annual COP of the unit itself. And as I said in the beginning, for us this is the most important value because it shows the efficiency of the whole heat pump. But how to get to that value is much more interesting, because here in the information table you see only one value, but to get that value you need to do your homework, and it's a quite big homework to do, because you need to go through something like that. We created a separate calculation sheet with all ambient temperatures from minus 15 down to plus 15 with variation of 1 degree, so minus 15, minus 14, minus 13, etc. up to plus 15. And in the standard you can find the number of hours per each ambient temperature, and in this case we calculated 2 cases for average temperature, and for average temperature it starts from minus 10, But also we did calculation for colder temperatures where it starts from -15, because our heat pumps can work down to -15. So for each of this ambient temperature, we have calculated the cooling capacity, then the energy consumption or power input, then the heating capacity, the supply temperature, and multiplied by the coefficient. At the end we get the different seasonal efficiency. For average climate, this is 5.8, like we already showed you here, and for colder climates it is calculated to 5.48, and both of those coefficients we believe are very high and very efficient for a unit like that. So with this additional information you can see how much effort you need to put to get this very nice value here. So these were our comments on the mandatory information requirements for heat pump table that basically needs to stay as a stamp, as a table on each heat pump, and we really hope that we were useful with our information. So if you have any additional questions, please mail us. Thank you.